Good morning, guys. Today we are going to discuss about AA linked list. So it is one of the variant of your linked list, single linked list and double linked list. Um, Already we have seen in detail about single linked list. Now we are going to discuss in detail in the sense how to insert, how to delete a node from a double linked list and how you traverse through that linked list is what we will discuss today. So what is the difference between a single linked list and double linked list? Single linked list is it has some restrictions like it can traverse only in one direction as it stores only the address of its successor. And if you want to find out the previous node, traverse back to move to the previous node, there is no option. And also the deletion and insertion of the previous nodes uh, can't be done easily as because you have to start the traversal from the first node to reach that I minus 1 or I minus 2 nodes of the list. So to overcome these, the double linked list have been used. So what is the use of double linked list? It will have both the links, to the successor as well as the predecessor. So it makes the traversal much easy when compared to single linked list. So each node of a DLL has three fields in general, but two of it should be compulsorily the link fields, one pointing to the predecessor and the other pointing to the successor. So this is how the node structure of a doubly linked list looks like. This is the data field and this is the pointer to the successor and this is the pointer to the predecessor. And this is how the class structure of the node of or node in a doubly linked list will be. So it is public and data and you are declaring two pointers, previous and next, and setting them to null. Previous and next is equal to null. Okay, so this linked list and double linked list maybe again in that also it can be linear or circular. So we have seen the major difference between linear and circular. Linear in the sense they will traverse in one direction, linearly. Here in double linked list you can travel back, but after reaching the end, if you want to come back to the first node, you have to come again to the header or the head pointer. You have to find out that, and then you have to start the traverse. But it's not the case in circular linked list, as the last node in the list is, uh, I mean, again linked to the first node of your list. So that is the reason it becomes a circular node. And again, these come with variations like with header node or without header node. So DLL may be linear or circular. DLL may contain a header node or may not contain a header. So DLLs are also called as two-way lists. So the other name for this DLL is two-way list. So how to create a double linked list? The program is the same as a single linked list, or the only thing is each node must be linked to its predecessor as well as successor. So this is the program. So all this program is in C++. So you go through it once, and we have just given we have written methods like how to create a node and how to append a new node, traversing, deletion of a node at a particular position, insert before a node, insert after a node, inserting at a position. So all these are the methods of which only get node and append node, create, traverse are given the descriptions. I mean, these methods are given the bodies, and the other methods are given the bodies. So next, so the main part comes like how to delete the node from a doubly linked list. So how to insert and how to delete. So first we will see how to delete, then we can easily understand how we can insert a node into a doubly linked list. So when you want to delete a node from a doubly linked list, the things which you have to change are the address in the previous node and as well the address in the successor. I mean the address in the predecessor as well as the address in the successor, because the linked current node points to its predecessor, and any node will point to its predecessor as well as its successor. So if, for example, let's take this is the node that has to be deleted. So you, and we treat it as current node. So what happens? So see, this node will have address of current previous here, address of successor here. So we have to exchange, I mean we have to set these links such that this address, the link or the link field of this predecessor node should point to this one, and the link field of the successor node should point to this one. So if you remove this current node, this is how it looks like after node deletion. Okay, so how will you modify the links? See, the current node's previous link. So actually this is the current node, the current node's previous link, and this is the next link. Because we have two links here, one to predecessor and one to successor, we are saying previous and next. So the current node's previous link is pointing to this address. So where it should be stored? It should be stored here. That is what we are doing here. See, previous current node's previous link should point to the next. So it will become current next. See, so this address has to go here. So this current node's previous uh, link has to go to this uh, next node, which becomes current next. This previous current node's next, which is pointing to this node. This address has to be stored here so that this points to this node. So the address here or the address here in the current node next has to be stored into previous. So that is what we are doing here. Current node's next is pointing to the previous, which is equal to current previous. Okay, current next and current previous. So this next node will point to this and this. So this next node will point to this. This previous node will point to this. So this is how your deletion of a node takes place, and this is the program for that. You try to understand the logic. behind these insertions and deletions. That is the main thing here. A program can be written, any one program can be written. No need to write all these programs. When we write the program, one program is enough. So creation of a double linked list. So this program is enough. No need to write a program for deletion and a program for insertion. So you just have to represent this logic and these steps properly. So finally, when you change the links, you will delete the current node. And next, insertion of a node in a double linked list. So how the insertion takes place. So when you want to insert, you have to change links four links in these pointers, I mean these nodes. So see, this is node 1 and node 2. You want a insert a node in between these two. So what you will do, you have to change the node 1 to next, node 2 to previous, current to previous, and current to next. So we will see here. So when a current node is inserted between node 1 and node 2, node 1's successor node changes. Yes? So because till now this link was pointing to node 2, but here it should now point into this node. And the same manner, node 2's previous will change, because till now it has pointed to node 1, now it has to point to the current node. So current is the node which is to be inserted. Now we have to set, till now it is empty. Now we have to set both the predecessor and successor for this, which is current being set to previous and current being set to next. So this is how it looks like when you try to insert a node in between node 1 and node 2. So these are the statements. Node 1 next becomes current, and node to previous becomes current. Okay, and current next will be your node to address, current previous will be your node 1 address. This is what we are seeing here in these statements. Node 1 next is current, node 1's next link will be current, node to previous link will also be the current. Current's next link will be, I mean, this link field will contain the address of node 2, and current's previous link will contain the address of node 1. So this is how you will be inserting nodes into a doubly linked list. Next, so if you want to insert a node before the first node, so how will you insert a node before the first node? So these are the changes you do. I mean, in when you want to insert a node at the first position. See head. So this head pointer has to be set. So your current next should be set to head, and head previous should be set to current, and the head will become is your current, and current previous will be null. So when you're setting a node as the head, the first node as the head, or the first node, you're replacing a head node with the current node, then these are the statements. The current next will be your head, head previous will be your current. Yes, head previous will be your current. So next this becomes head is equal to current. Yes, now this is the first node, so this current now becomes head. So the previous node is won't be there for this head node, I mean, which is now current. That is the reason we have set it as current previous is equal to null. So once again, see, current next is your head, because we are changing the head node to the current node. I mean the pointer which is pointing to the first node, we are setting it to the current node. It should become this first node, the head node. So current next is equal to head. Head previous is equal to current. Yes. Now after changing these two, your head will become the, I mean your current will become current node. I mean your current node will become the head, and your current previous, I mean the current node's previous link is set to null because there is no node existing before this node, because this is itself the head node, the starting point of your list. So this is all about your doubly linked list. And traversal, how you traverse in a DLL. So given a head point for DLL, traversal is also the same as single linked list. The advantage of DLL over single linked list is the in DLL we can traverse in both forward and backward directions. In single list linked list you can traverse only in one, that is forward direction. Again, if this DLL is circular, it has more advantages compared to a linear DLL. So whatever we have seen now is a linear DLL. And in next class we will discuss about circular linked list. Thank you.